Crystal symmetry. In this section, we will discuss the types of symmetry used in classifying a crystal and classification of crystals using examples of real-life minerals. Crystals are classified using 3 degrees of symmetry. 1 plane of symmetry. 2 axis of symmetry. 3 center of symmetry. A plane of symmetry divides a crystal into similar halves. For example, a cube has 9 planes with each plane a mirror reflection of the other. Image that you have a cube of sugar or Maggi in your left hand. Try and divide the cube into equal halves using a knife in your right hand. There are 9 possible ways to divide the cube. 1 from north to south, top, side C. 2 from east to west, top, side C. 3 from east to west, from the side A. 4 diagonal from left on side C. 5 diagonal from right on side C. 6 diagonal from left on side A. 7 diagonal from right on side A. 8 diagonal from left on side B. 9 diagonal from right on side B. The diagram shows the 9 planes of a cube. If a crystal is rotated from a particular axis and it comes to a similar position more than once a 360-degree turn, the axis about at which the rotation occurs is called axis of rotational symmetry. The axis may be twofold or dyad axis, half-turn or diagonal axis, threefold or triad axis, fourfold or tetrad etc. In a cube there are 3 axes of fourfold equals 3 4. 4 axis of threefolds equals 4 3. 6 axis of twofold equals 6 2. This diagram illustrates the 3 major axes of a cube. A center is present in a crystal that is bounded by similar faces occurring in parallel pairs on opposite SDES. All crystals have a center of symmetry. All crystals can be grouped in one of the 7 crystal systems by determining their plane of symmetry. P. Axis of symmetry, 3 axes of 4 center of symmetry, 4 axes of 3 folds. The 7 crystal systems are listed in the table 9 planes and 1 center. Crystallographic axes are imaginary reference lines chosen to be parallel to the intersection edges of major crystal faces. The internal symmetry of crystals are referred to possess a set of 3 or rarely 4 reference axes or crystallographic axes. Most times, these crystallographic axes coincide with symmetry axes. There are 2 groups of crystallographic axes. 1 orthogonal. In this group, all the axes are mutually perpendicular or 90 degrees to each other. Example: the cubic, tetragonal and orthorhombic system. 2 non-orthogonal. In this group, the axes are not mutually perpendicular or 90 degrees to each other. Example: the monoclinic and triclinic system. The hexagonal and trigonal systems have unique z-axis that is perpendicular to the horizontal plane containing 3 axes mutually at 120 degrees. Cubic system, all the axes are equal and they are perpendicular to each other. Examples are halite, NaCl, magnetite, garnet. Tetragonal system, all the axes are not equal, A and B are equal but C is shorter or longer. They are perpendicular to each other. Examples are zircon and cassiterite. Hexagonal system, all the axes are equal. 3 axes are 120 degrees to each other but the 4th axis is at 90 degrees to the other 3 axes. Examples are apatite, beryl. Trigonal system, all the axes are equal. 3 axes are 120 degrees to each other. Examples are calcite, dolomite, tourmaline. Orthorhombic system, all the axes are unequal and they are perpendicular to each other. Examples are olivine, andesite, barytes. Monoclinic system, all the 3 axes are unequal and they are not perpendicular to each other. the B-axis is perpendicular to the plane containing A and C axes. Examples are pyroxene, amphibole and orthoclase. Triclinic system, all the three axes are unequal and they are not perpendicular to each other. Examples are plagioclase and axonate. Questions. Answer the questions below by choosing one of the options. For a cube the axes are 3 AV, 4 AII, 6 AII, 9 P, C. This means 3 axes of 4 folds, 4 axes of 3 folds, 6 axes of 2 folds, 9 planes and 1 center. For a cube the axes are 3 AV, 4 AII, 6 AII, 9 P, C. This means 3 axes of 4 folds, 4 axes of 3 folds, 6 axes of 2 folds, 9 planes and 1 center. For a cube the axes are 3 AV, 4 AII, 6 AII, 9 P, C. This means 3 axes of 4 folds, 4 axes of 3 folds, 6 axes of 2 folds, 9 planes and 1 center. For a cube the axes are 3 AV, 4 AII, 6 AII, 9 P, C. This means 3 axes of 4 folds, 4 axes of 3 folds, 6 axes of 2 folds, 9 planes and 1 center. For a cube the axes are 3 AV, 4 AII, 6 AII, 9 P, C. This means 3 axes of 4 folds, 4 axes of 3 folds, 6 axes of 2 folds, 9 planes and 1 center.